All right, good morning, everyone. Welcome to another Living Freestyle Game Dev live stream. My name's Kevin. We do these twice a week, Wednesday nights it's Wednesday morning. Wednesday mornings and Sunday nights, 8 a.m. Wednesday mornings, 10:15 Sunday nights. That's all Eastern time. This works like a Q&A AMA office hours. The idea is to hopefully help out with any kinds of questions as far as Unreal, blueprints, game dev, etc. I am fortunate enough to work in game dev professionally. I currently work at Riot Games in R&D as a tech artist. So I have a pretty good foot in both sides as far as the tech and the creative aspect of it. And I definitely don't know everything. So a lot of this would be potentially stumbling through, trying to help you all out. I learn as much from you as hopefully I can help you learn as well. In general, if there are no questions, that's not a problem. In the absence of questions, I am just currently live streaming, working towards my own personal game and a working prototype. Right now, we are mostly working with AI and trying to get them to behave a little bit better and hopefully start to balance out our game to be a little bit more, actually just to try to find the fun, basically, is where we are. There's going to be some bigger updates that we need to do. Things like updating to Unreal 5.1, updating our animation system, a whole bunch of stuff like that. But we're not going to get into that during the live stream. Hopefully I'll be able to do that offline. So with that, I didn't see any questions in any of the chats, and I also didn't see, there aren't any questions yet this morning. So as previously, we're going to hop right back into our game. We have our controller connected, our music rolling, and hopefully all of our streams are up and running. We are trying the dual stream thing again. If you notice any problems with the streams, please feel free to throw just some kind of heads up in the comments. And in general, we will get going. All right, we've got our we've got Unreal. Let's kind of find our brains here for a second because we just got rid of Unreal. There we go. And where we left off, we don't need any of that stuff. Where we left off is we were starting to balance out our enemies again. So we have one enemy, and let's just figure out where we are again, okay? So let's play. First play of the day always takes a little bit. You also have to successfully have clicked the button. I'll bring up the chats just to make sure I don't miss anything. All right, I've got my sword, my weapon. We have one enemy. Okay, so she goes. This is what we were working on last time. She runs for the health, picks up the health. She's healed now. She should come back and start attacking me again. Okay, couple things that we had noted last time. When I stand still, if I move over here, I stand still, she takes up an attack position around me. You'll notice it's just behind my back left shoulder. So let's go ahead and try that again. Same spot every time. This works great, I guess, if you have a horde of enemies. But it doesn't feel... it feels very predictable right now. I hadn't noticed it before because we always had multiple enemies, but she'll switch sides probably. Let's see. I think it's based on which way my pawn is going, so let's just double check. Maybe not. Oh, it's based on... Okay. It doesn't matter which way I'm facing. It's based on world space. So I think if I'm facing this way, she's back over my left shoulder. If I come over here and I face this way, she's going to take up her spot. But if I face what I think is world forward, now she's doing the same thing again. All right, so that's something that we could fix, and I definitely think we should fix. And or we could get back into attacking and balancing. Let's see if we can think about this right now, because basically, because she's not attacking or anything right now, it's super easy to try and test out alternate options for that. So let's take a look at our behavior tree and figure out where she's deciding to attack from. I believe behavior tree. Also, this only happens for melee. Let's take a look at our enemy behavior tree. All right. In here, we're strategizing. We're directing to our enemies, and then we're going to fight. And inside fight, this is our ranged attacks, finding all of our cover positions. And I believe this is, we're checking our health. This is a random attack, okay. Interesting. When does that happen? Should we fight? We get our target enemy. We check our health. Whoa. I need to refresh my brain on how this works. Setting our focus. Okay, I think I have a better idea of what's going on now. Okay. We disconnected their ability to attack when they were fighting so that we could do the debugging. And that's what this bit is here. Okay. We're basically checking our character health, and then we're doing a melee attack here. Now what's interesting to me though is we're going to pop down in here. We're going to force success here. We're going to check our health, and we're going to do all of this. I don't see where it's picking this attack for melee or for ranged and this attack for melee. How does our game work? And then over here, all right, so we're basically checking the health all the time. This is our loadout. We're always, let's see here. Okay. This may be also part of what we disconnected. All right, so this is cool. Can we do this here? Wait, hold on a second. We need, first off, we don't have perforce up. E4. Let's connect perforce. And connect to perforce. And accept. I guess we can't do a diff on a behavior tree. Is that true? Oh, what a bummer. Okay, there's another way we could do this to double check, but I believe this is exactly just what we did. We just disconnected all of this, which is the attacking, and our meleeing, so that our enemies, this is kind of answering our question too, so that our enemies wouldn't attack and we could easily troubleshoot. All right, now, when this is fine, we have to be coming in here. You know what? Let's just watch this. Something's weird. Because it's almost like it's doing both. Let's see if we can watch this. What do you mean you can't find member actors? Oh well, it found one. Okay, so it definitely went through here and now it's in here. It moves to, it waits. Basically, okay. Why didn't it go through here? Oh, we do have a decorator. I guess I wasn't reading well. Interesting that we're not hitting this breakpoint. Okay, I see what happened. All right, this is why, this is why it's important to work cleanly. So this should melee is labeled incorrectly. You'll notice this, the decorator is actually called BT decorator should melee, but the description under here is check character health. So let's just fix that because that caused us to go in circles. Should melee. And in our decorator, the custom description is should we, or technically what it's doing is it's like, do we have a melee weapon equipped? So let's just keep it as should. Or actually it's called should we melee, and melee weapon equipped. Let's call it, let's try that. All right, compile and save. We'll check that out. And then over here, you'll notice that fight. Here we go. Melee weapon equipped. And we could actually put a question mark in there too. Compile and save. All right, that actually helps us understand that a little bit better. All right. Now remember, this is the negative of that because we've inverted the condition. All right, and so what we end up doing is we end up coming down here to do our melee weapon equips, and then once we're in here, now we're starting to roll, we find our attack location. All right, now this is where we do all of our fun stuff. Now, we get our weapon ranges, etc. We get our objective actors, etc. This is the one that kind of gets all of our ring positions. And the way this works is it basically creates a loop for our positions, and it uses the actor location plus a rotator, which is rotated in Z based on the number of slots. So the number of slots times our index. We subtract 1 from that. We're going through the for loop. We divide that by 360. That's going to give us the number of degrees. Then we're going to add 60. We're adding 60. Why are we adding 60? Okay, let's do this. I want to draw a debug sphere so we can visualize this. And we're going to draw a debug sphere at this position point. Okay, but I'm going to draw two different spheres here. And the reason is because I want to, actually, no, we're not going to draw two spheres. We're just going to, we'll do something a little more creative. Let's promote this to a variable. Actually, we're going to promote it to a local variable. And this is going to be debug sphere color. We'll default it to bright blue. We're going to set our radius to 60, our duration to 1, and our thickness to 1. And then what we'll do here is a test. If our index is greater than 0, we're going to set this to be, let's say, a lighter blue. Okay? Now what this is going to do is visually, although it didn't look like it took lighter blue. Oh, we need to increase our, right, click OK. And then we're going to draw our debug spheres. Now, ultimately, this we're going to, let's just group all of this together because this is going to kind of be for debugging purposes. Once we finish debugging, we're going to want to take this out. So I'm going to take all of this and let's just comment this as debug. Debug ring position. And let's start doing this so that maybe all of our debug blueprints comments are going to be yellow from now on. Try to get a little more consistent in here. Okay? So now when we compile and save and we play, we should see all of our debug spheres once she sees me. Right now she's just patrolling. She hasn't seen me yet. Or he, I don't know which one we got. There we go. Okay. So we got our colors opposite, but that's okay. We saw them show up. You can see where they're showing up. It would actually be, we can eject now at this point. Excuse me. Excuse me. Okay. When we eject, you can see basically these are all the, it's kind of cool. This is all the attack positions that a character can take when they want to come in and attack another player or character. Now in this case, they're always starting from the same point. And the trick is that every single enemy, okay, we're going to need more than one enemy. Here's the trick. The trick is every single enemy is going to get the next available attack position. So if I do, let's just do 6 enemies here. You'll notice right, this is going to chug because they're all drawing. Can't see. Okay. So they're kind of getting in position. So they all I'm not sure why they're moving around right now. Why are they moving around? I don't know why this player or this enemy is not settling into a position. Okay, we need to figure that out first. Okay, so let's do this. If we come back to here and we only want to do this. We only want to do these debugs, draw these debugs one time. Or another way to do this would be, because the problem is it's drawing these debug spheres for every single enemy. Let me just reconnect this in and think for a second. The other option is, once we're done, this is our attack ring claim. That's the int. True. False. And the way this is organized is a little bit weird. So we get through, we get all of our attack ring claims. We go through, we do them all. And then we set the attack ring claim to the index. Okay. Can we draw a debug number? Or debug? Let's do text. Bizlog text. Nope. Text. Never tried to draw a debug. Arrow, box, circle, cone. Coordinate system. Debug float history location. What does this give you? Oh, that's interesting. We could use that. It seems kind of complicated. I know what we might be able to do. Rather than a sphere, what we can do. Oh, okay. I know what we need. Let's do lines. Let's draw a debug line. Draw debug line. This will totally work. We're going to draw a debug line, and the end point is going to be here, and the start point is going to be our actor location, which we haven't set, but we can just, obviously this is not the best way to do this, but it will totally work. So let's bring this down here. We'll do a line color that we can see. And then what we'll do is we'll do a duration of 1, thickness of 1, again, and here we go. So what's going to happen is now when they do their debugs, they're going to draw a line from where they are, or, oh, interesting. I'm getting bumped around. All right, everybody settle down. Okay, so now, so that's the dude that I'm trying to figure out where he's going. Oh, frustrating. It's so hard to debug. I'm also getting killed here. The other thing is, they're not drawing. Where are they drawing this arrow from? This is the actor location? Oh, well, that's not gonna help us. Okay, that's wrong. We were using the actor. We were basically using the actor that was part of the that we're basically ringing around. That's not what we want. And what we want is do we not have a handle to, yeah, get owner, get blackboard. Okay. That's the blackboard. Is this the only place we do this? Find references. We only have one get owner in this whole thing. All right. And then when we're done, for that blackboard, let me get the controlled pawn here. Yes, we can. All right. And with that, actor location. And with that, that's going to be our start. So this should draw lines from them to where they're going. There we go. That's what we wanted. Okay, everybody is settled into place here. Of course it works now. Nobody's moving. Nobody's trying anything funny. They're all within their range. So if I move now and they go to readjust, that all, she's in a weird spot. Like where she just moved to. Oh, okay. I think I know what's happening. In here. Wait. Find random attack location. Here's my guess. What's happening is we're not coming through this ring positions. So why wouldn't we do that? We wouldn't do that if the actor to anchor around was failed. So let's put a breakpoint here. Okay. Or brute force line check. What is her? It's a slow morning for us. Okay. Basically, I just need to know which one she is. That's not what I want. Okay, so he's 5. I think she is. He's 2. She's 3. I believe the one that I'm looking for is 3. Okay. So if we switch this to 3, see what she's doing. Yeah, look at this. She's coming through here. Wait. She's supposed to come through there. False. Draw a debug line. My ring claim is less than 0, or the projected point to navigation does not succeed. Interesting. Why would that be true? Basically, what's happening is the projected point doesn't, for some reason, is not actually getting put onto the nav mesh. Okay. So basically what we're doing is this is our ring claims. We're claiming one. We're also projecting that point to navigation. Hold on a second. If we don't have a ring claim, why are we... All right, by this time, we're checking our positions. If it's valid, then we're checking to see if the ring claim is less than 0, or if the position is good. So wait, if the position is... So this is basically all the negative. So if our ring claim is bogus or the position's not good, then we're going to come down here. Otherwise, for false, we skip all of this. And what does all this do? This goes through the ring claims. Array element. Oh, it looks for a new ring claim. Gets that. Okay, it finds the next one that does project to a mesh. And then when we're done, we come back up here. We come back in, and we set our attack ring claim. Or no, we get our attack ring claim and we get the position. And that's where we end up going. Oh my goodness, this is confusing. Who made this? All right. We may need to simplify this. I think what's happening is our check for projecting the point is potentially failing. So if our ring claim is less than 0, or our projected point is not valid. So if either of those things are true, we're going to loop back through the ring claims again. And that happens after we get our owner. We go through. We get our ring claim. If it's greater than 0, then we check to see that the target, and though that we're using the same target. Okay, that way we're not trying to ring up around the wrong enemy. That's true. Then we're setting the ring. Okay, so what this does, all this does is, here, let's comment this. Jeez Louise. The problem is it's been so long since we've looked at this, we can't remember what it does. All right, so all this does, this doesn't actually set ring claims. Okay, this sets the all current ring claim values. All right. Then with that, we're checking to see if we have a valid index. And if we do, we check to see if my ring claim is less than 0, or the position is bogus. If either of those are true, we need to get our ring claim. All right, just cleaning this up. If our index is invalid as well. These are both reasons that we need to, this actually, we don't have it. This is basically, we don't have a good ring claim. So we need to get the next available one. Okay, that's good. All right, and then theoretically, when we're done, we're checking as we go to make sure that the point projects to the mesh. I don't know why we're adding 0 here. This is kind of weird. So if the ring claim is less than 0, or the point is bogus, then we're going to get a new one. All right, this is where I think we might finally be getting down to it. I think this might be happening. So let's see if we can prove this out. And to do that, what I'm going to do is I'm going to separate these. So if our ring claim is less than 0, okay, hold on, we're going to need another one of these. So if our ring claim is less than 0, okay, we're going to need to get a new ring claim. All right, if our position, so this is where our other one comes in, if our position is bogus, we need to get another ring claim. So basically what we've done here is, rather than doing it all at once with this or, I'm doing them separately so that I can print a string. And here what I'm going to print is projected position is bogus. And I'm going to make this red just for the purpose of debugging. Give me a second to read it. And now hopefully we can finally try this out. Everybody's getting to their spots. Okay, everybody's settled in. That's good. Nobody's moving around. That's good. If I move, everybody seems to be settled in again. Let's go back the other way. Okay. Doesn't seem to be a problem right now. See, but I don't know why this dude just moved. All right, so he's not, this guy is not moving because yeah, he's not moving because the nav point is failing. He's moving for some other reason. Like, where's that guy going? Part of the problem here is when they go to move, they don't go around, they go through. Like the pathing is everybody's where they're supposed to be now. They settle in. Somebody's out of place. Okay. There. Why did that guy just move? That's what we need to figure out. This bottom left corner all of a sudden just walked. Oh. Hold on a second. I think I know why. Maybe. All right, so what might be happening is maybe he's trying to move close enough in to attack. Let's see if we can figure this out. Okay, so if we should melee, we find a random attack location. We move to our move goal. Okay. I never saw this. We never saw that. The bogus actor. We never hit that breakpoint, so that's fine. What is this doing? This gets our ring positions and sets the values. And it sets the value for the move goal of our move to location. The other reason that we would potentially have a different thing is, like I said, bogus actor, which we never saw print and we never hit that breakpoint, so that's not it. This one, ooh, brute force line of sight check. Target enemy. Normalize line trace by channel. Oh, this is all about if it's true, we set our actor to position around, we cast to it. When are we coming through here? We're coming through here when this condition is true. We're coming through here after the reachable random point and radius is false. Print string. Reachable false. Okay, let's check that. All right, everybody moves in. All this positioning, none of this is because the point is not reachable. Oh, there we go. So reachable was false there because it was too close to a wall. I imagine we'll get one here. Yes, we do. All right, if we can get to a position where they can all get around me. Okay, reachable is false quite a bit, actually. Okay, so if reachable is false, what in the world? Target enemy last location is a value. What does this have to do with anything? Why is this even here? Oh. Okay. Hold on a second. Goodness gracious. We need to clean a lot of this up right now. Okay. All right, I guess it's a blueprint cleanup day. Let's go. Just make this so we can actually follow the flow. I don't know why this isn't even being used anymore. This used to check has target line of sight. We're not doing that anymore. We're brute forcing it. So let's just get rid of that for confusion. And we're brute forcing it because I guess I remember vaguely setting all the line of sight stuff just wasn't working using the behavior trees. Let's just get all this to a point where we can read it. Okay, now the original intent behind this line of sight was for weapon fire. And the idea was that, wait, let's see here. Let me double check before I confirm that. We basically come into find a random attack location and we check our equipped weapon attack range. This is our searchable radius. Okay, we set all of our blackboard values. This is all the standard stuff. Then we get the controlled pawn. We set the move to location to where we are right now. Right? Makes sense. We check to see if we're in sentry mode. None of these characters are in sentry mode. And so we definitely get false. Then what we do is we take our target enemy So we take our controlled pawn, we're casting that. Why is this all a spaghetti mess? What happened? Seriously, what happened? Okay. This isn't even being used. Socket locations. This is a plus. This is going to be our start. And our end is here. All right, can I even read this now? All right, so we're coming in here. We're getting the control pawn. We're checking to see if it's one of our characters. Great. Then we're checking the target enemy, and we're also checking to see if it is one of our characters. If the cast fails, we go to false. Okay, that's fine. I am not going to do this inside here. I am going to cross the streams in this case. Come on. I'm going to cross the streams in this case because I think that will be cleaner. All right. Same thing with this one. If this is false, I believe goes into there. Okay, that's fine. All right. Now, if both of these are characters, that's great. That's what we want. Then what we're going to do, nope, is we are going to get the head sockets for each one. And we're going to do a line trace, basically. So we get the socket for the target, and we're subtracting. So we're getting a vector from basically the AI's head to the target's head. We're going to normalize that. And then, what is this? Target enemy. Okay. So then we're normalize that. Then we're multiplying by 50. Why are we multiplying by 50? And then we're adding in our head location. So basically what we're doing is we're creating a line that comes from our head, pointing at the other character, and we're multiplying it by 50. So that basically, 50 seems short. And then what's going to happen is that is going to be we're going to do a line trace from that point 50 units away to, oh, I see. We're going out from our head 50 units in order to get away from our own character's body, for example, or sword or whatever. So 50 seems like a lot. 25. Okay. And then if we hit, and the character that we hit is the enemy, that means we can see that character. Interesting. Okay, here's the problem. hold on, I'm thinking. All right, so if we hit the enemy, then we come about and we go about doing the stuff we were doing before. Now, there's a couple problems that we need to sort out here. One of them is this find random attack location is only done for melee. It's a little bit of a misleading name for our blueprint too, because we're no longer finding random attack location. This is finding a melee attack location. And it's not always random. Generally speaking, it's a ring around the enemy. In this case, which is the player. And so what happens is, if we don't find a ring or something else is going on, then we will find a different spot. And we do that false controlled pawn. Oh, interesting. True or false, actor to position around. Hold on a second. Maybe this is truly a random attack. Okay, we get it. Can we see the enemy? We can. We set our attacker to position around to be the target enemy. Makes sense. And then we come into the get ring position. If we don't have line of sight, then we pop into here. Okay. Then what happens is, then it does become truly a random. It just finds a random reachable point. Okay, I think I figured out what's happening. Oh my gosh. We're running out of time, but I think I figured out what's happening. Basically, what happens is our characters all kind of ring up. They get in all their spots. But the problem is, when they're in their ring positions, there might be another ally standing between them and their target. And when that happens, when they go to check the line of sight on the target, they think they don't have it because their line of sight, they're hitting their ally along the way. And as a result of that, what happens is they come in here and it basically says they don't have line of sight, which pops down into here, which gets a random point in the radius around our last known enemy location, which is 200, which is a very small radius. The reason this was intended for, like, if we lost sight, if we had lost our line of sight, we would go to that position and then go there and start looking around. I don't know that that's the behavior we want. If we don't have line of sight, yeah, okay, we can keep that. But what we need to do is we need to change this. This line trace, let's do a multi-line trace. Now, there's a couple different ways that we could do this. I think what we want to do is rewire this. Okay. We're going to go start and end. So what we're going to do is we're going to change this to be a multi-line trace, which means it's going to and we could have done actors to ignore. That's one way we could have done it. Or what we're going to do is for the out hits, we're going to go through for each of these, we're going to check. Okay, we're going to need a variable here. We're going to check the hit. Okay. We're going to check the hit to make sure the hit is our enemy. And if it is, we need to set. Okay, so let's create a variable here. As target B, this is a Boolean, as target line of sight. All right, and what we're going to do is when we start, let's just set that to false. Okay, and then down here, if this is true, at any point, if they're equal, I need to make sure that, okay, so this should be has target line of sight now. Okay, and if this is true, we're going to set this to true. So for each one of these hits, we're going to do this. Okay. And then when we're done, we're going to go back about what we were doing. And at this point, what this should do is this should prevent us from not seeing the target because our allies are around us. So let's see if we were right. We'll do one more test and then we'll wrap up for today. All right. Everybody's getting in position. Interesting. There's one enemy that's stuck behind a wall. Okay, everybody's in position. We're just watching to see if that one dude in the corner just randomly walks into a spot. Five enemies. Looks like one of our enemies is stuck in a wall. He's actually stuck in a wall. Okay, we need to restart this. All right, everybody. Form up. Okay. One of our characters. That's pretty good. This dude is no longer randomly moving towards me. And I think it's because actually, yes, he is. Why is he randomly moving still? He's still moving. I'm looking at this guy right here. Hold on. We have our problem case. This guy back here in the back left corner, where's he trying to get to? He draws his line back to there, and then all of a sudden he goes forward. Why does he go forward after that? So here he is, he goes back to here. Now he comes forward. Why? What call is that? All right. I don't think we found it. I think we did some good logic, but I don't think we found what is causing this character to do that. So we are out of time for this morning though. So let's go ahead and wrap up. All right, today was kind of a slow day. I think multiple enemy AI debugging is tough because I think we need to get nameplates above our characters. We may need to come up with ways of freezing other characters, right? Like maybe if we mouse over somebody and said stop moving or stop thinking or something, because it's really just the one dude that's the problem. And I want to figure out why. I just got to find where in the logic tree he's going that is causing, in that case, I mean, the enemy changes what he's doing. But anyways, I need to find where in the logic tree the enemy is going that is causing the enemy to bounce back and forth between where they're supposed to be and their attack ring positions and randomly just running next to the character. And I feel like it's because they're losing line of sight. I thought that was a pretty good lead, but perhaps not. So I guess what I'll do is I will try to dig into this a little bit between sessions. And again, we'll be back Sunday night, 10:15. As always, if you have questions, throw those in the comments. If your question's complicated or etc., you just want to just hop in the next live stream and we can answer it live. That'll work as well. My name's Kevin. Again, it was good hanging out, and I will catch you all on the next live stream. Have a great rest of your week, everybody. Later.